Hello everyone, it's Jasmine again. This time again without Vedran, and we are continuing my quest on trying to create some sort of a home lab that makes sense. I started with Proxmox, then I upgraded Proxmox to a cluster, then I created a Ceph storage, then I am now working on different other things that make sense when it comes to having your own home lab. Today join me while I try to install Prometheus in order to create some sort of monitoring so that we can actually see what is happening inside our home lab and try to establish what can be done next. So let's start the intro and see what's next for the ThatITShow. Hello again. So I'm now in Portainer. My Portainer installation is something that we already covered. It's basically an Ubuntu server that is running a Docker, and then inside this Docker is Portainer Community Edition running basically to enable easy working with different storage devices, different Dockers and everything else, simply because I want to make things as easy as possible on me. I could do it via command line, but what I want to do is I want to try to do it over the web. I'm going to make mistakes, and I'm going to try to solve them, because this is my first time running Prometheus from Portainer. I'm usually deploying it directly from command line, and also there is one thing that needs to be noted. Prometheus as such is one of those things where that you deploy once and then use for years. It is not usual that you are redeploying or starting deployment of a new monitoring tool every couple of weeks. So when you deploy something, you usually stick with it, simply because it's usually complicated to configure it, and also you want the monitoring tool to run as often as possible because you want information. You don't want to change source of information every few weeks. So let's go and see what we need for the Prometheus. What I want to notice first is that Prometheus is probably one of the singlest and the easiest to install applications there is. The reason is simple. You just have a Docker image. That's it. They have their own account on Docker Hub. It's called Prom. They have a Docker image. It has been downloaded over 1 billion times. It has only two stars, but I guess this is something that is completely fine. I don't find any problems with it. There are also a couple of different Docker images also offering Prometheus, including one from Canonical for Ubuntu specifically. But I'm going to go with the official one because this is the one that can be easily displayed and easily explained by using official documentation. Anyway, you're going to end up with the same thing anyways. Now, let's quickly go through what documentation tells us, and let's quickly go and try to explain things that we are interested in. If I go into documentation and if I go to the installation part of the Prometheus documentation, I can see that it offers me quite a few ways of installing it. Now, I'm not going to use precompiled binaries, so I'm not going to go with the precompiled binary section. I could, but I much prefer using Docker. And the reason is the most of the reasons why I like it this way is the ability to upgrade. So I want to be able to upgrade the Prometheus as easy as possible, and as it says here, running it can be as simple as Docker run something, but then you need to set up some things in order to not lose your configuration every time. Now let's quickly go through the documentation that we have, and let's quickly go and try to explain what is here, what makes sense, and what and why are we doing some things that we're going to be doing. So first, let's talk about the volumes. A Docker image, when you start it, doesn't have permanent storage. So what you can do, or what you must do, is you need to create a storage source, so either a bind or NFS or whatever, and you need to bind it or to install it inside your Docker. If you don't do this, you can also run your Docker, but then it is going to make your life much more complicated, since the Docker itself, when it updates, what it does is it destroys the old Docker image and uses new one, and then it binds the directories that you mentioned. If you store your files inside your Docker, you're going to lose them. So what is going to happen is that your file is going to get lost with the old image. You're going to get a new image, but without the configuration. So what Prometheus tells you to do is that you basically create a couple of volumes and make your volumes available from a local computer, so the computer that is running the Dockers, directly to the Prometheus Docker. Now, what you can do is you can provide the directory or the files that you want to provide directly, and you can also provide the location for the Prometheus data, because the data itself is going to be stored in the Prometheus directory inside the container. So every time you restart the container and you redo the container, the data is going to get lost. We obviously need persistent storage, so we need our data to be available. So we also need to do the volumes. Then what also is mentioned here is that you can also bake the configuration of the image, so that you can also just create your own line when you're creating a Docker file. So you can just get the configuration for your directories directly into the image. But since I'm using Portainer, it's probably easier for me to just do the configuration directly from the Portainer itself. Now, let's start doing this. Let's go to the Portainer, and let's first go to the volumes. What Prometheus wanted me to do is Prometheus wanted me to create basically two volumes. One volume would be for the configuration, so I'm going to call it Prometheus config. I'm going to go with, this is going to be a local drive. I'm going to put it locally, and I'm going to say create the volume. So this is pertaining, this is called Prometheus config, and it is going to be somewhere. Now, then I'm going to create another volume, and this volume is going to be called Prometheus data. And Prometheus, yes, data, I'm going to create the volume, and this is going to be it. Okay. Now, I have my volumes configured here. I have some volumes that are the result of the Dockers that I used last time I was showing something, so I'm just going to go quickly and say I don't need this WordPress and I don't need this WordPress, and I can just go and remove them just to clean things up. Okay, so now I have two Prometheus configurations or two Prometheus volumes that are going to be permanently stored on my local computer, so that whenever something changes in my Docker, the files change on the local computer. If I need to change the Docker itself, the files are going to just survive and be on the location that I mentioned. Okay, this is the first thing. Now, the second thing, let's create the container. I could either go and grab the image and then create a container out of it, or I could go and do the container itself. Let's go with grabbing an image and doing whatever needs to be done. I know what the image is called, so I'm just going to go here and copy the name of the image from Prometheus. And I'm going to go here and tell it, okay, I need this image here, and I'm going to pull it. Now, if everything is okay, and I have no reason to believe that it is not going to be okay, my image is going to be pulled, and now I have my image pulled here, so I have Prometheus latest, which is unused, here. So I have the volume, I have the image, or to be more precise, I have both the volumes, both the image, and now what I want to reference is the configuration that the installation of Prometheus told me to do. So what they told me to do is to first map port 9090 to port 9090 on the host itself. Then they told me to map the etc Prometheus in the Docker into my volume that is called Prometheus volume, whatever. And also they told me to map the /Prometheus directory to my Prometheus data the volume, so that I can actually have my data available across the installations. So let's do the containers. Let's say that I want to create a new container. I'm going to go with my local container here, so I'm going to go with Prometheus. Okay, I'm going to go, I want my Prometheus image. I can go and say always pull the image. No, because I don't need to. I have my image here. I don't need the webhook, and also I cannot use it because this is the business feature. Then I can publish all exposed posts to the random host ports. No, because I want to be able to influence this. Now I need to do other things. Under here, I'm going to first do the network. So my network is going to be the bridge one. I'm going to call my so I'm just going to go with the container. Just give me a second. I'm looking for bridge volumes. I want to have my mappings here. I want to map my host port 9090 to 9090 TCP. Okay, I want to create my volumes here. I want to didn't change anything in the network. I want to map additional volume, and what I want to do now is I want to tell my container that path into container, and this path is going to be etc Prometheus, is going to be mounted to Prometheus config, and then I want to mount my /Prometheus data. So this one, I want this to be mounted to Prometheus data. Okay, so I mapped my image, gave it a name, told it to map my ports from my host directly to my container. I mapped my volume called Prometheus config to etc Prometheus. I mapped my Prometheus data to Prometheus directory. And this should be it. Now, if I have done everything correctly, if I deploy the container, this should work. Now, since my container is local and my image was local, it's going to be extremely quick. The reason is that it just needs to start it and map the ports. This is going to be it. So now my Prometheus host actually runs. What I can do now is I can go and to see what is mapped here. I'm going to try to open it, but I don't think that since I did give it the IP address, it doesn't know which address it is connected to. So I'm going to say that this is 1189, and I'm going to 168.1.189 1990 is going to be my Prometheus host. Now, Prometheus by itself, it's not that interesting right now because I have nothing. I don't have a table, I don't have any queries, I don't have any explain, so I don't have anything. I don't have no rules. My status is that I have what I can check is my build information because it has been built, it works. I can check my target health. It is going to be fine because my host is running. I can take a look at metrics of my host. But the thing that right now is interesting is that my Prometheus host itself is not working correctly. So I need to 181, if I'm correct, 189, sorry. So I can see my metrics data, but this data is unreadable by people. So this is metrics data that Prometheus sends to itself. So this is basically a list of things that Prometheus is able to provide for itself. Now, I now have my endpoint. My endpoint is working. It is up. I'm collecting data from it. So now I can do queries when I need to do something. For example, let me find what can I do. I can explore the metrics. So for example, let's say I want to see let's find something interesting. Let's say go threads. Let's see what the metrics is. So I can now see my two back to all the metrics. I'm going to go the instance. This is the first one. Okay, I'm going to insert and I'm going to execute it. And now I can see that when I look at the threads, I can see that there is 14 threads done by Prometheus on my host. This is just a start. I have created my Prometheus host. Now my Prometheus is collecting data. But the thing is that this is collecting data only from my local computer, and it doesn't make too much sense. Right now, it doesn't make too much sense to have this thing only set up, and that's it. So now what we need to do is do something more. Now for the next thing that we can do is we could create graphs. The Prometheus itself permits you to query the database it has. So it is basically talking to itself and saving the data. And then you can go and fetch the data from the database to create graphs and to do different things. Let's create something simple. Let's say that we want to graph, I'm going to explore the matrix, and let's say that I want to graph the number of processes, maximum number of, let's try to find something that is going to be process number, or the not Prometheus process number, but the process itself. So maximum number of, okay, let's add gauge. It is going to be CPU seconds for the processes, and let's execute this query, and we can see this. Now what I have done is I have created extremely simple query here up here, and then I gave it the I basically told it to I want this query to be on this graph, and wanted to see it in a time on a time scale. This time scale is going to start when my data collection started, basically a couple of minutes ago. And I wanted to told it they want high medium resolution. High resolution would be better. Low resolution would be low. And this doesn't make much sense right now because my data set is extremely small. So I have so small number of data points that this is not going to make any difference. But with a large enough data set and with wide variance when it comes to data points, this could prove to be different, extremely different, and maybe faster or slower depending on the resolution that you are aiming for. Also, there is an update. Or fixed resolution graph that you can say, okay, I want to see the data that was given to me every 5 seconds, 10 seconds, 30 seconds, and so you are basically refining which data do you want. And for example, 1 hour of data that doesn't mean anything, but 15 minutes would give me just a straight graph, while 10 seconds would create something that is as close to the data that I have right now available. Now, I could theoretically now go and grab different different graphs and use this. But in the next episode, I'm going to be talking about Grafana, which is much more efficient and much more user-friendly when it comes to creating graphs. Also, it is much more capable in creating graphs. So I'm just going to right now stick with what Prometheus can do, and I strongly suggest that you take a look at the Prometheus itself and see what Prometheus permits you to do. Okay, now when you are doing the things like this, so when you are executing a query, for example, something like this, and say execute, you can see what is happening with your queries. Why this is important? This is another thing that is part of the Prometheus. When you are dealing with a large number of machines, and I have seen installations that were running thousands of different sensors or thousands of different nodes that are able to provide data for Prometheus. When you're dealing with that kind of complexity, you want to understand how your queries are working, because you want to know how much time did it take for the result to appear. So you want to understand how complex a query is in regards to what you have in your database, in regards to what you're trying to display. This specifically something that is going to deal with or you're going to deal with this when you try to optimize some of your queries in order to get a data set or a graph or something that makes sense to you in a given amount of time. Because you don't want your database server or your Prometheus server to constantly query something and always be behind the information that you can get. So you are basically using this to, let's say, optimize the time it takes to load something, and you are optimizing the so you get the result, and you can see how much time it took to load it. So this is something that is used for optimization. The graph itself is used to get the data displayed. You can then deal with the graphs, and you can add different queries to the graph. You can add different things. So Sorry, I just wanted to keep the regular thing up. So this is it. And you can work with this. Now, let's talk about how data actually gets into Prometheus. In order to do this, what I need to do is I need to connect the data source. I'm going to go first and use my OpenSense. I have an OpenSense running since a couple of months ago when I was doing the episode when I was putting my Proximus cluster online. And my Proximus cluster was connected to the internet through my PVE, my network. That was my local network called Local Bridge. I was using my OpenSense. My OpenSense was VMBR1 was my connection to the local computers. My VMBR0 was connection to the internet. And my PVEs all got VMBR1, so I was able to do VMBR1, and connect to them. So I have my three machine cluster of the Proxmoxes, and I'm going to put them up to see if they're able to even start with this configuration. Let's see, my PV2 is starting, my PV1 is starting, my PV3 start. So far so good. So I have my cluster up and running, and I have my OpenSense up and running. I want my computer Docker test, which is using my Dockers. I also want to connect it to my PV and OpenSense in order to gather some data about Proxmox and some data about OpenSense. Now, in order to do this, they have to be in the same network. I could theoretically use the VMBR1, which is the network that connects to my local network inside my house. But this first doesn't make sense because this is the outside network looking from the perspective of the Proxmox and the OpenSense. And also, I don't want to, I want to create my own home lab. So my PV1, PV2, PV3 and OpenSense are basically part of my lab. So I want my Docker test machine to be available locally from the PV hosts. So what I'm going to do is I'm going to go here and I'm going to just VMBR1, set VMBR1 as one of the devices. So now my Docker test has a bridge connected to me so that I can actually go and operate on it. So I can open my Portainer. So this one, so I can see that my Prometheus is running. Now I have my Docker test here. I have my Prometheus running on this machine, which is also the Docker host. And now my Docker host is also connected to the other machine. Okay. Let's now talk a little bit about how the data is being connected and how the data itself is available for Prometheus. Prometheus does things a little bit different than what you would expect when it comes to data collection. And I'm going to open the Prometheus documentation to try to explain a few things. So first, Prometheus is not intended to, by itself, to run something calling an agent. They're doing something called node exporter, or to be more precise, the server itself is the idea of the server itself is to go along the network and to try to explain how, to try to connect what is happening on the network itself, or on the monitor devices. Now, this may sound strange, because this is something that you want, usually you want the agent to push to the Prometheus server, not vice versa. But also this enables the Prometheus servers to connect to different servers, and also to be able to actually go and check if the server that they're monitoring is online. Now, what does this mean? This means that we have a different things that we can do and different ways that we can monitor different things. Now, when you install your Prometheus, server, this is just the first start. There is a project called Node Exporter that is a binary that you can install on any computer or any Linux, whatever machine there is. That is going to expose different collectors or different pieces of information about your machine. There is an exporter for Linuxes and Unixes. There is an exporter for Windows that is called Windows Exporter, that is more or less the same. And you can configure not only the system, but you can also configure which what information do you want to make available. And then you need to tell your Prometheus instance that you want your Prometheus to talk to the servers themselves. So what you need is, you need to have some sort of an exporter. By exporter I mean data exporter on the Prometheus. You need your computers. You need Prometheus server, and then the Prometheus server is going to talk to your different machines, and it is going to scrap or get the data, and then this data is going to get loaded or get introduced into your database, and this database is then going to show you the information that you want. To try to explain this, I'm going to grab this official image from here, from the Prometheus website, and I'm going to say that we have installed Prometheus server right now. We have a node, we have our retrieval system, database, and HTTP server. So HTTP server is serving the pages. We have our retrieval agent. Now, it is able to go to exporters. So we call them exporters or targets, the computers that we are monitoring, and each monitor has to have its own exporter system installed. It could be a node exporter, it could be anything else. Also, different systems can have their own gateways that are going to do something and then exit, and then give the information, push the information that the Prometheus can grab. Think of it like jobs or services that are running infrequently, and they're just having some sort of a result. So for example, overday or overnight, you're doing some sort of data collection, you do an average or you do a report, and then this report gets published. And this is not a dynamic thing. This is going to just change once daily or twice daily. So you have it ready for the Prometheus to grab it. Also, different other targets or exporters are available for different systems. Also, there is a service discovery and the Kubernetes port that is able to communicate with Prometheus to give you Kubernetes health information. There is something called Alert Manager that is able then to use Prometheus, information from Prometheus, to create alerts through either PagerDuty, which is a commercial service, but also emails, SMSs, and so on and so on. And there is an API from QL that enables you to do more data visualization and do the export through API calls to other clients that are requiring Prometheus data. So basically, Prometheus is the central storage space for all the data about your system or your your environment, and then you can either pull metrics from other systems, or you can give other systems information that you gathered, or you can push alerts. When it comes to exporters, there is a huge list of exporters. So, for example, AWS, Consul, Elasticsearch, MySQL, MS SQL, Redis, Raven, Postgres, IBM, Netgear, NVIDIA, Windows, and so on and so on and so on and so on, that are able to expose data to Prometheus. So you install this thing. For example, let's click on Windows Exporter. You go here, you install your exporter, you make it run as a service that is going to be enabled on this port. And then when you do this, your Prometheus server, wherever it is going to go to this port and grab the information about the system, or the Windows system that you set up. Now, the thing is that these exporters can be either programs that you install, or it can be just plugins, or even part of the system itself. And one of those that we are going to be showing you is going to be the one in the pfSense or OpenSense that we are going to be showing you. But we are going to be leaving this for the next episode. Until then, this has been a short one, but a nice one. I'll see you then, when I'll try to explain to how the Prometheus thing works, and we'll be setting up a small setup that is going to enable us to monitor our Proxmox system. Is going to enable us to monitor our outside firewall, and to see all of those things at the same time and in the same place. Thank you for being with me, and see you in this next episode.